Alright students, welcome back to the next part. In previous part we discussed about the basics of circuit switching and we mapped the switching layers over TCP/IP. Okay, let's talk about circuit switch networks. A circuit switch network consists of a set of switches connected by a physical link. So we have a switch, which is this part over here. This is all a switch. So we have our physical links. This is one physical link. This is another physical link. A connection between the two stations is a dedicated path made of one or more links. So if you want to go from here to this station, there are multiple links through which you can pass from A to M. Each link is usually normally divided into N channels by using FDM or TDM. If you remember chapter number 6, we did talk about multiplexers, and you can see the switching is basically incorporating the multiplexers, and these multiplexers can be either using FDM or a TDM. So over here in this picture you can see we have a network in which we have 4 switches, 1, 2, 3 and 4. Each link is divided into N channels by using FDM. So they are like N channels, 3 here, 3 here, 3 here and 3 here. So they are usually N channels, but we can see there are only 3 channels here. As we explicitly shown the multiplexing symbols to emphasize the division of the link over channels, even though multiplexing can be implicitly included in the switch fabric. So what he's trying to say is like ये जो आप लोगों का switching fabric पूरी ये पूरा fabric लगा हुआ है switching का, तो ये multiplexes नहीं दिखाए जाते, basically ये अंदर छुपे हुए होते हैं. तो basically यहाँ पे इन्होंने बताने की कोशिश की है कि इन switching के अंदर आप लोगों ने multiplexes भी इस्तेमाल किए जाते हैं. The end systems, these are M systems 1 and 2. These are switching elements here. The end systems such as computers or telephones are directly connected to a switch. Of course, they have to be connected to a switch to do communication. We have shown only 2 end systems for simplicity. When end systems A, which is over here, A, needs to communicate with the end system M, which is far apart, a need to request a connection to M that must be accepted by all the switches as well as by M itself. So it has to make a request here, it has to make a request here, it has to make a request here, and it has to make a request here as well. So there are 1, 2, 3 and 4 sections. Well, this is not the only path. It can also try the making of connection from this way, and then eventually the end has to accept the request as well. So it can be either way, it depends upon how busy the network is. This is called a set of A's. So what we just did is like we asking for the connection. If you have connection, please provide me a connection. I want to go to Mr. M, and this circuit switch network communicates with this one, asking for ports, and then this one will be asking for ports from this one, and eventually it will reach the M. This is called set of A's. And the combination of circuit or channels define the dedicated path. So this will be a dedicated path, like a telephone line, dedicated line from here till here. Once you pick up the call, whether this person is talking or not, this line is active. After the dedicated path made for connection circuits is established, when they agree upon that we have the ports available and we can make a connection from A to M, the data transfer phase can take place. So this A will start sending data, which can be signals. If we are talking about FDM, this is FDM, and it will be packets. If we are talking about the multiple packets, if we're talking about TDM, not TDM, the other one. Which one is a circuit switch or packet switch? Sorry. Okay. After all data have been transferred, the circuits are torn apart, torn down. That means when this system A completes the communication with station M, it has to disconnect all the connections that are made here. So it will disconnect all, release all the connections, making available for the others as well. So Mr. M was busy. So what happens in the telephone lines, you already know that when you are making call, nobody else can call you over the telephone. So this is the same case with the circuit switching. So we need to emphasize several points here. Number one, circuit switch takes place in physical layer. Sorry, takes place at physical layer. Before starting communication, the station must make reservations. That means you need to do a setup phase. This is called setup phase. Whether we are using FDM or we are using TDM, and then when all the data has been transferred for the duration of the time, whatever it is, we need to tear down the phase. This is called tear down phases, where we take the connections back or the busy ports back. Data transfer between the two stations are not packetized. There are no packets. The data are continuous flow sent by the source station and received by the destination station. So this part here, we will using this part, circuit switching, not this part. No packets, only signals. Although there may be a period of silence. So this one talking to this one, yum 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 yum. This one only listening. So the part of the time, if because the thing is like there is only there's not simplex from here to here and then simplex from here to here. There will be two lines. All right. So this one is listening, this one is talking. The listener's time, the part of the connection is basically idle. So next thing which is very important to understand here, there is no addressing involved during data transfer. No addressing, no addresses are there. The switching routes data based on the occupied band FDM or time slots TDM. Of course, there is an end-to-end addressing used during the setup phase. We will see that shortly. So addressing from here to here is allowed, but there is no address from here to here basically. All right. Okay, let's talk about some examples. You can see a network here. This is basically a circuit switch telephone network. Let us use the circuit switch network to connect 8 telephones. So we got 4 telephones on your left side and we got 4 telephones on the right side. So what we can see here, we assume that each link uses FDM. So this link is either FDM or it is either TDM, doesn't matter. Connects maximum of 2 voice channels. So we can connect only 2 voice channels here and we can connect only 2 voice channels here. The bandwidth of each link is 8 kilohertz. So we can see that each channel is 8 kilohertz. So we know that voice need 4 kilohertz. So we can send 2 channels of voice 1 here and voice 2 here. So we can divide it 4 and this is 4. So that means 2 voice channels can pass through. The bandwidth, telephone 1 is connected to telephone 1 is connected to telephone number 7, if you can see from here. So it's like Mr. Ali is talking to Mr. Sheikh, and on the rest of the lines there are girls. All right, so they talk too much. Yes, of course situation may change when new connections are made. So this is at the moment we are connected. So situations may change when, let's suppose, Mr. 4 need to talk to number 6, or similarly 5 to 3. Switch control all the connections as well. All right. So let's move on and check out another example. In this example, we can see there are computers connected to the other side of the computers. So So consider a circuit switch network that connects computers in two remote offices of a private company. The offices are connected using a T1 line. Now this T1 line is quite old. When these are called leased lines, they were like 1.544 megabits per second lines. When we were using dial-ups, these lines were like the daddy of all the lines anyway. The offices are connected to a T1 line leased from a communication service provider. That means some ISP is in between. There are two 4 by 8. These are 4 by 8 inputs and 4 inputs and 8 outputs. Switch in this network. For each switch, 4 output ports are folded onto the input ports to allow communication between computers in the same office. Like if you want, if like suppose this one wants to talk to this one, so this fabric will move the communication back here. So this is like a loop back. 4 other output ports allow communication between the two offices. So these 4 allow the communication between the two offices. So we have two things here.